thought this might help using Loggerpro. I'm going to go ahead and do one of the examples that we've been working on the last couple of days, or I should say that you guys have been working on in class for the last couple of days. So let me go ahead and get started on this. We're looking at this right here, this set of data. What I want to do is input this data. So I'm going to rename my column headings. I'm going to make this is my X over here, and this is my Y. So I'm going to rename my two X and Y columns here to match my data set. So this, instead of being X, is going to be time. Let me go ahead and put in time here. Whoa. And the short name is going to be T, and the units were in seconds. So I am now done. I'm going to rename this. What am I going to rename this? Velocity. Okay. Same thing. V for velocity. V, and those units were meters per second. And squared. I can put a superscript up there. Squared. There we go. Done. All right, now I want to type in my data. Uh, 0.3, 1.2, 2.7. So 0.3. One point two, 1.7. Boy, I hope this is right. Oops, 2.7. All right, so it's 2.7, 4.8, 7.5. 2.7. I don't remember. 4.8, 7.5. 4.8. 7.5. And what else do I have? 10.8, 14.7. 10.8, 14.7. And then last but not least, 19.2. Alright, so I'm going to go ahead and put in, this is 10, 20, 30 all the way up to 80. So that's easy. 10, 20, 30, whoops. 30, 40, 50, 60, 70, 80. Alright, you can clearly see this is not a straight line. You can start to see this curve. Something we can do is auto scale this from 0. I kind of want to see the top of this a little more. I want to see where that ends, so I can extend this. Just click on that, make it 90, and that makes me able to see a little more of the graph. Options, you can either get the options this way, graph options, or you can get the options here, graph options. What I want to do is turn on point protectors, shut off connect the points. It's done. You can see this is curving. So curving, curving, curving. You know, just to see that it's clearly not a straight line. I mean, I can throw a straight line on there and you can see this does not fit very well. I got a point down here. It kind of curves off this way, and this goes straight through here. Let's see here, just to write this down, I've got a correlation of 0.9762. That's close to 1. 0.9762. 2 is my correlation. I'm just kind of writing it down. So that I have note of it when I go back and check my next graph. I'm going to shut this line out of here so I can see if this winds up being better when I graph it again. So I need to get some data here. I'm going to go to a new calculated column. This is a side opening parabola. So in order to straighten out a side opening parabola, I'm going to square the y-axis. So I'm going to square velocity. So when I get my new calculated column, I'm going to square velocity. So I'm going to call that velocity squared, because that's what I'm doing to it. Short name is going to be v squared. And the units, since I'm squaring velocity, which is in meters per second squared, whoops, that should be meters per second. I got to fix that. I'm going to wind up with meters squared per second squared. So it's going to be meters squared per second squared. I'll fix this in a second. Alright, so here's what I need to do. I need to square the velocity. So I'm going to go to my variables column. I'm choosing velocity because that's what I'm going to square. And this works just like a calculator. So what I'm going to do is I'm going to put in a caret and a square, and I'm done. And what will happen is that'll give me that new column. I want to fix this. This is in meters per second. Done. There we go. All right. Notice my graph still looks the same. I've still got this curve because I'm still graphing velocity versus time. To switch this to velocity squared versus time, I click on the label. I change it to velocity squared in meters squared per second squared. And my graph seems to have disappeared, but in reality, it's still there. But what I need to do is auto scale so it winds up on the graph. And there it is. It's a nice straight line. Let's see how nice a straight line it is. It's got a correlation of 1, which is great. So there we go. I got an excellent correlation, a nice straight line. I can see it fits through every point. Now I'm ready to go ahead and write the equation for my line. I've got a slope of 333.3 meters squared per second squared per second. We'll talk about the units in a minute. And a y-intercept of 0 meters per second squared. So that really doesn't matter to me. All I'm really interested in is this slope right here. And I want to write my equation for my line. So move this over here. And go ahead and write this down here. So my correlation was 0.9762 for the last one, for that first graph. This is clearly better. 1, that's really what I'm looking for. So I'm going to get rid of that, and I'm going to go ahead and write down the equation for my line. It's going to be in y equals mx plus b form, but instead of y, I'm going to take what I graphed on my y-axis to get that straight line, and that would be velocity squared. So that's going to be the short name, which is going to be v squared, is going to be equal to the slope, which is going to be 333.3. I've got meters squared per second squared per second. I got to address these units. Let's go ahead and do this now. I've got meters squared over second squared, and that's over I'd like to get a different color. Yeah, we'll do this. That is over What is that over? That is over seconds. So what happens is I've got the bottom of the bottom. Wow, this is weird. That is meters squared per second squared. It's going to be change y over change in x. Yeah, that's what that is. So what happens is the bottom of the top goes to the bottom. So I wind up with meters squared per second cubed. Ugh, that is some ugly units. All right, so I'd have seconds times second squared, which would give me seconds cubed. Yeah, that's some really ugly units. All right, well, let's see how this works out. And that would be times the y-axis, which would be time. Oh, I got to get my units in here. Meters squared per seconds cubed times time. And then that would be plus the y-intercept, which is 0. So I'm not even going to include that. I'm just going to take that out of there because it's 0 anyway. So this is the equation for my line. This guy right here. That is my equation that relates these two sets of data, the velocity and the time. Oops, and I still messed this up because that is supposed to be right there. That's supposed to be cubed. So let me fix that. There we go. Seconds cubed. That's what I'm interested in. I took that right off of the slope and the y-intercept. And you can even see it starts to give you the, if you put in the units, you can even get the equation. It's v squared is equal to mt plus b. All I got to do is put in my m. It's all written there for me. All I got to do is copy it onto the page. So this is a great tool.